This is Module 6, Scatterplots and Two-Way Tables homework. Okay, the first question says, look at the scatter plot below. And it says, which statement describes the data? This is an example of data displaying a linear association. No, it's not linear because it doesn't fit a line, does it? This is an example of this data displaying a nonlinear association. This is true because what you would see is basically a curve here. Okay? Is it a positive association? No, because here it's positive and here it's negative. This is an example of data displaying a negative association. Well, this part would be negative because it's going down here, but the key is it's nonlinear. Okay. This is 2. The scatter plot below shows a relationship between the number of hours spent studying, see, time studying hours, and the scores earned on the driver's license test, a percent of correct answers on the test, okay? Which conclusion does the scatter plot support? The two variables are not associated. Well, I would say that's the case because there doesn't seem to be any way to fit them. They're definitely not negative because they don't go down. There's not a trend positive. It's just simply they're not associated. Look at the scatter plots below. Match the description to the scatter plot that most likely shows the association described. Okay. All right. Scatter plot A. Here are the scenarios. Money spent on video games in a year for the X and number of pets owned. Do you think there's any correlation between those? Probably not. That'd be scatter plot C. The monthly average temperature and the time spent wearing a coat. Well, as the temperature goes up, the time you spend wearing a coat goes down, right? So I would think that would be a negative association. All right. The age of a middle and high school student X and their height. Well, as they get older, their height should go up. That would be scatter plot A. Sophia works part-time at a grocery store. One of her responsibilities is to place oranges into plastic bags and weigh them. She then records the number of oranges and the weight for each bag. One of her records is shown below. Construct a scatter plot to represent the data. Okay. Oranges. Let's see if that is our x-axis or our y. Our x-axis is oranges. Our y-axis is the weight in pounds. So we've got 3 oranges, half a pound, okay? So number of oranges, 3. That would be at half a pound, right? There's our half a pound right there. Here's 1 point. Then let's see what we've got here. 3 oranges, 1 pound. Okay, so let's plot the 3 oranges, 1 pound. Ooh. We may have to, let's do this. Let's, let me try plotting, showing you this. 3 oranges, half a pound, 3 oranges, 1 pound, 3 oranges, 2.5 pounds. So let's do all of that. I'm going to bring it so it sits right on number of oranges there. 3 oranges, half a pound. I have to go back up to look to see, get my other numbers. Three oranges, 1 pound, 3 oranges, 2.5 pounds, okay? 1 and then 2.5. So let's do that. Three oranges, 1 pound, all right. 3 oranges, 2.5 pounds. That would be right there. Okay. Let's find our other oranges. Let's see, it says when we've got 4 oranges, we got 1 pound and 1.5 pounds, okay? 4 oranges is 1 pound and 1.5 pounds. So we're just plotting our data. Let's see what we've got for 5 oranges. 3 pounds, 4 pounds, and 3.5. 3, 4, and 3.5. 5 oranges would be 3, 4, and 3.5. All right. Let's see about 6 oranges. 6 oranges, we got 3, 4.5, and 5. 3, 4.5, and 5. Now we've created these scatter plots. See how the data is scattered around. There is an increase. There is a linear association. Okay. Let's go to the next problem. Scatter plot below shows the relationship between the number of hours driven and the total number of miles driven. Well, as you drive longer, you should have gone more miles, right? Which statement correctly describes the relationship? The relationship is positive? Yes, it is, because it's going up, isn't it? Okay. Choose all that are correct. The line of best fit will pass through the origin. Yeah, if you drew a line of best fit through these points, it's going to go right through the 0, right? The relationship between the variables is nonlinear. No, it's linear. There's no relationship, no association. That's not true because it's a linear relationship. The slope of the line of best fit is negative. No, it's positive. The relationship between the variables is linear. Yes, it is. Megan measured candles that burned. Which graph shows the height of the candle in relationship to the amount of time it's burned? Time, height. Well, if it's burning, the candle height should go down, right? Here it's going down and then going back up. How's the candle going to get shorter and then get longer if it's burning? The only way that's going to work is if as time goes on, the height of the candle goes down. This one right here. The results of a football punting and kicking contest are shown in the scatter plot. The values on the horizontal axis represent the punt distance, and the vertical axis is the kick distance. Okay, where's the outliers? Well, this is not the outliers. Outliers are the ones that lie outside of where you expect them to be. These would be outliers, okay? These are outliers. Look at the scatter plot below. Which graph shows the best line of fit? Well, that one's not really because it's kind of cocked to the side. This one's got too many underneath it. It's got too many above it. This one makes sense. It's got about half of them above and half of them below, and it seems to have the right trend. A teacher studies the relationship between 5 of her students' scores on 2 quizzes by plotting the scores on a scatter plot. Plot a line that best fits the data. Okay, you must graph the line using only 2 points. Well, if you're looking at this, guys, to draw a line of best fit, okay, I don't have a good way to do this, but essentially, oops, you need to do it with a straight edge, and your line of best fit is probably going to look like that, okay? But you need a straight edge to do it, okay? Kelly bought a treadmill and tracked the number of hours she used it each month. Okay, now look, the number of hours seems to go down the longer she owns it. Kelly modeled the data above with a straight line. What kind of slope does this line have? That's a negative slope. So that's a negative relationship. It says that the longer she owns it, the less time she spends using it. A teacher took a survey of his 8th grade class. After finishing his survey, he found that there was a strong positive linear correlation between the number of hours the students spent studying and the students' grades. Which of the following graph shows this? Strong positive linear. There's a strong positive linear, right? Strong means that it's close. This one's no association. That has a negative, that has a strong negative linear. This one's not linear, it's a curve. Roberto made this scatter plot to show how the school record in the boys' 400-meter run has changed over time. Okay. He drew the line of best fit. Which is the best interpretation of the slope of the line? That slope is going down, isn't it? Okay. The school record has decreased. Okay. So we're talking about what is the best interpretation of the slope, not the y-intercept. These deal with the y-intercept, the slope. The slope has decreased at a rate of 0.04 seconds per year or 0.08. Well, that's fine too. If you drew a line here, I don't have a good way to draw a line, I don't think, with this. Let's see. If I drew a line, then we need 2 points to find the slope, don't we? All right. If we take this point and maybe this point, something like that, we know that our slope is change in y over change in x. All right. Change in y, let's see, from this, let's see if we can find a point that's better. What if we took this point and took, well, no, this is about 50.5 down to 49. This point here would be at about 0, 50.5. This point here is about what? 1549. So x, y, 0, 50.5, 15, and 49. Okay, your change in y's would be 49 minus 50.5 over 15 minus 0. That would be negative 1.5 over 15. Okay. Negative 1.5 over 15. It's closer to 0.1, so your school record decreased by, this is going to be the closer one, 0.08 seconds per year. Okay? Let's go to the next one. The study of middle school students finds that the total number of minutes a student spends on a computer each evening, C, is linearly related to the total number of minutes the student spends completing homework that evening, H. So this is the minutes they do homework, and this is the amount of time they spend on the computer, okay? Given this model, which statements must be true? On average, this is homework that's on the computer, all right? Total amount on the computer. 1.5 times the number of hours. Let's see, study finds that the total number of minutes they spend on a computer is related to the number of minutes they spend doing homework, okay? So 1.5 times the number of minutes on homework plus 62.1 give you total amount of time on the computer. On average, for each additional minute spent completing homework, the student will spend 63 additional minutes on the computer. No, this is what they start with if they don't do any homework, right? In general, the more time a student spends completing homework, the more time the student spends on a computer. Well, that's true. The more time they spend on homework, the more time they spend on the computer, because this is a positive relationship. Okay. The model predicts that someone who spends 15 minutes on a computer in the evening will spend 84.6 minutes completing homework that evening. Well, let's try that and see. 84.6 minutes. Let's plug it in. The total amount of time on the computer, if that's equal to 1.5 times, let's see, what did they see? 15 minutes on the computer in the evening. Oh, it doesn't deal with homework, okay? If they spend 15 minutes, you have to put 15 minutes there and see what you got there. I don't think that would work. If a student does not spend any time on homework, the model predicts that they will spend about 62.1 minutes on a computer. That is indeed true, okay? All right. There you can see. Now, 14. A researcher studies the relationship between the number of hours of sleep per night and the performance on a memory test, okay? Study participants are randomly selected to get no sleep or sleep in 1 hour increments up to 8 hours total. That is, the participant gets 1 hour, 2 hours, 3 hours, so on up to 8 hours. The researcher determines that the association between the two variables can be modeled with this linear relationship, where H is the number of hours of sleep and P is the percent score on the memory test. Use the slope on this equation to describe the association between the hours of sleep and the performance on the memory test. Okay, we've got P is equal to 9H plus 15. Which one's the slope? We know in linear equation y is equal to mx plus b. So your slope here is 9, okay? But 9 what? Well, let's see. This is essentially your y, so we need to know change in y over change in x. What are our units? Our y is our p. Our p is the percent score on the memory test. So this is percent score, okay? And your H is the number of hours, okay? So this means you go up 9% on your score for each additional hour that you sleep. The two questions below were asked of teachers at a school at which the students wear school uniforms. Have school uniforms improved the learning environment? Do you think students should continue to wear school uniforms? Okay. The table shows the results of the survey. Which conclusions about the results is valid? Okay. In this, let's see, 14 were in favor of uniforms and thought it improved learning. 2 were in favor of uniforms but didn't think it improved learning. 0 were opposed to uniforms and thought it improved learning. And 4 were opposed and didn't think it really improved learning. Most of the teachers surveyed were in favor of having school uniforms, okay? Most were in favor, okay, because they do not believe it improves unit. What? No, they were in favor because they thought it improved it. Most of the teachers surveyed were not in favor. That's not true. Most were in favor. Most of the teachers surveyed were not in favor. Nope. Most of the teachers surveyed were in favor. Yes, okay. Okay, of having uniforms because they believed it improved learning. Okay, that's where this is. In favor, improved learning. Irene surveyed 100 people. See, they don't have our totals here or here, do they? You have to add those yourself. She asked each person, do you speak a second language? Do you play a musical instrument? The results are summarized in this two-way table. Irene believes that musicians are more likely to speak a second language than people who are not musicians. Does the data support her claim? Choose the best answer. Let's see. Plays a musical instrument? Yes. Speaks a second language? Yes, there's 13 of those. Plays a musical instrument? No. Speaks a second language? Yes. Plays a musical instrument? Yes. Speaks a second language? No. But plays a musical instrument? No. Speaks a second language? No. She believes that musicians are more likely to speak a second language, okay? Musicians are more likely than non-musicians. Yes, yes, play musical instruments, speaks a second language, 13. Okay, speaks a second language, doesn't play a musical instrument. No, that doesn't make sense because more of them that she surveyed didn't play a musical instrument and spoke a second language than those who did play a musical instrument and spoke a second language. No, let's see. So the answer is no, because approximately the same percent of musicians and non-musicians speak. No. No, because only 40 of 100 people surveyed speak a second language. Okay, let's see. No, because only 40 of 100 people surveyed speak a second language. Let's see. Well, that would be, that's true, but let's see. There are only 19, yes, because there are only 19 musicians who do not speak a second language, okay? Essentially, guys, it's no, because approximately the same percentage of musicians and non-musicians speak a second language, okay? There you go. The movie theater concession stand had a total of 350 customers on Friday. 175 bought popcorn, 150 bought a fountain drink, 50 bought both popcorn and a fountain drink. Fill in the two-way table below to summarize the data by dragging and dropping appropriate numbers into the box. Okay, so let's see if we can't put these into the box. Let's do this. Okay, bought a fountain drink and bought popcorn. Bought both popcorn and a fountain drink. That's 50. Let's see, bought a fountain drink, didn't buy popcorn. Bought a fountain drink, no popcorn, 150. So the total of that is 200 people. Didn't buy a fountain drink, bought popcorn. Popcorn, no fountain drink, that's 175. Didn't buy fountain drink, didn't buy popcorn. Okay, bought, let's see. Bought both popcorn and fountain drink, bought popcorn. Okay, there are 350 customers. Okay, so we got to find this one, don't we? Okay. The total here, 50 plus 175 would be 225, all right? We've got a total here of 350 who were there. If you subtract 200 from 350, you got 150 here. So 175 to get to 150, that's not right. Did not buy a fountain drink. Bought popcorn, did not buy fountain. We did buy popcorn, did not buy a fountain soda. Bought a fountain soda. Wait a minute. Got to go back up. I'm missing something here. There's a total of 350. Okay. 50 people bought popcorn and a fountain drink. Very good. 175 bought popcorn. Oh, that should be over here. Bought popcorn. I put a couple of these in the wrong spot. Let's fix this. Let's start over. Okay, a total of 350 customers. That goes here. 175 bought popcorn. Let's see. Bought popcorn. That's here. 175 bought popcorn. 150 bought a fountain drink. Let's see. Bought a fountain drink. That would be a total over here. 150. 50 bought both popcorn and a fountain drink. Fountain drink and popcorn. 50. Okay. So if this is 50, that's got to add up to 150. This is 100. Okay. If this is 150 and that's 350, our total, then this has got to be 200. 350 minus 150 is 200. Okay? I've got 175 there, and this is 350. So what I need to do is I need to say 350 minus 175. All right, let's just make sure we get this right. 350 minus 175, and that would be 175. This is 175. These two have to add up to 175, so 175 minus 100 is 75. These two have to add up to 175, so 175 minus 50 is 125. Okay, so we've now created our table. Two groups of volunteers participated in an experiment. One group was asked to drink tea at 7 p.m. each night. The second group was asked to turn off all lights and electronics for 30 minutes before bed. After 1 week, all participants were asked if there was improvement in their quality of sleep. The results are shown below. Okay? It says those who had tea, 16 said there was an improvement, 12 said no improvement. Of those who turned out electronics, 10 said there was an improvement, 8 said there was no improvement. Okay, so remember, they have not put our totals on these, have they? Okay, and so the first question they asked me deals with totals. So let's make sure we put our totals on here. You put total under here. You can put total over here. Continue on my little table. All righty. If I did this, I've got 28 here. I've got a total of 18 there. I've got a total of 26 here. I've got a total of 20 here. I have a total of 46 here and 46 there. A total of 46 volunteers participated. What percent of the participants who drank tea each night reported improvement? We're not going to deal with this one because this is of those that drank tea. If you were going to do that, you'd say what percent of the participants who drank tea? Those who drank tea, there was a total of 28. What percent of those reported improvement? That would be 16 out of 28, okay? That would give you 16 divided by 28 times 100. That would give you 57%. Okay, approximately what percent of the participants who spent 30 minutes without lights or electronics, that'd be 18 people, reported improvement? 10 of the 18, okay? That would be 10 divided by 18. See, we're not doing that because we're not going to do anything but our totals here. That would give you 56%, okay, of those. All right, so we're done with that question. Let's go to number 19. Dana surveyed her classmates and found that 15 watched TV every night. Watch TV every night, 15. And 10 do not watch TV every night. Of those who watch TV every night, 8 said that they read for fun, 8. Of those who said they do not watch TV, 5 said they read for fun. Use this info to complete the two-way table. Well, if you go across to get the total, you'd add those two. 8 and 5 would be 12. 8, let's see. No, sorry. 13. Can't add tonight, sorry. Okay. 8 plus 7 gives you 15, so that needs to be 7. 5 plus 5 gives you 10. 7 plus 5 gives you 12. 13 and 12 gives you 25. 15 and 10 give you 25. There's your completed two-way table. And let's do the last one. In a random sample for a survey, High school freshmen were asked whether or not they play sports. The responses are recorded with the size of the school the student attends, Division 3A, Division 2A, Division 1A, whether they play sports or not. Okay. The two-way table summarizes the results. Which statements are true based on the survey results? Choose all that are correct. Freshmen who play sports are more likely to attend Division 1A high school. Those who play sports, let's see. What percent of those? No sports or no sports? High school freshmen. Let's do our totals. We're going to need our totals here. We're going to need some percents here to understand our results. So let's get us some totals so we can do some percents. See how we're having to add our columns and rows here? Let's see. Division 3A, we've got 164 people. Here we had 132. Here we had 80 people we're talking about, right? Okay. Now, freshmen who play sports are more likely to attend Division 1A high schools. Out of all the freshmen who play sports, we have a total of numbers who play sports. So let's add it across. 4, 10, and 15. That's 14 and 15. It's 29. Okay, here are the ones that don't play sports. Let's see. 160 plus 122 plus 65 would give me 347. Okay, say more people don't play sports. Okay, let's see the total number of people that were surveyed. 164 plus 132 plus 80. Total surveyed is 376. Okay. Now, let's look. 15 out of 80 out of your Division 1 play sports. Let's see, 15 over 80. That would be 19% for Division 1. Okay, 10 out of 132. 10 divided by 132 would give you 7.5% for Division 2. And then 4 divided by 164, that would be 2.4%. Freshmen who play sports are more likely to attend 1A schools. Yes, this is a higher percent of those. Of the freshmen who attend Division 1A schools, 65% do not play sports. Let's see, that would be 65 out of 80, so no, that's not 65%. Freshmen who do not play sports are more likely to attend a Division 3A high school. 3A, yeah, this was because those who do not play, 160 out of 164 is a higher percentage. 98% of these did not play sports in 3A. All right. Of all freshmen surveyed, about 7.6 play sports for a Division 2A school. Okay, Division 2A, freshmen, that would be 10 out of 376. Let's see. 10 divided by 376 times 100 would give me about 2.7%. So no, that's not right. All right. And then the majority of freshmen do not play sports regardless of school size. That's true. Okay, let's see. Let's check Division 1A. 15 divided by 80. Okay, definitely. Okay. That's the end of that homework assignment.